You know, there are some very special right triangles that I want to share with you because they're really sort of easy. When we sort of see them, we can actually extract a lot of information about them. Let me begin with sort of the isosceles right triangle. This is a right triangle where the two legs have the same length. So two legs are congruent. Kind of look like this. If I call this, let's say, A, then this would have length A. And since it's an isosceles triangle, we know that these angles here are going to be congruent. And so what's their measure? Well, if this is 90 degrees, the entire triangle sum of angles is going to be 180. 90 are here. That means that we have to share 90 degrees equally with each of these. So this is a 45-degree angle, and this is a 45-degree angle. And sometimes this is called a 45, 45, 90 right triangle, an isosceles right triangle. Well, what is the length of the hypotenuse? Well, we can actually figure this out using Pythagorean theorem, because we know, if I call this h, that h squared is going to be equal to a squared plus, well, b squared, but now that's the same thing as a squared. So I see that h squared equals 2, remember 2, a squared. I take the square root of both sides, just the positive one since h is a length, and I see h equals the square root of 2a squared. But that simplifies to just square root of 2 times a. And so what I see here is that this length is given to be the square root of 2a. So whenever we see an isosceles right triangle, if I know this side, then I automatically know that this side is going to be the square root of 2 times, this hypotenuse is going to be the square root of 2 times that. It's really easy. And you can go the other way around too. If you know this length, then we can find this length by taking the other length and dividing by square root of 2. The 2 comes from the fact that I have two sides that are equal. Let's check out some examples together. So here I have a right triangle. It's right. And I see this angle is 45 degrees. That automatically tells me, since this is 90, this has to be 45 as well. So in fact, this is an isosceles right triangle, or a 45, 45, 90 triangle. These angle measures are equal, which means that this length I automatically know is 11. And if I want to find this hypotenuse, I know exactly what it is. I could use the Pythagorean theorem with 11, 11, and x, or I could just remember what we just did and realize that x equals 11 times the square root of 2. Pretty easy, pretty easy. Let's try another one together. This one's a little bit trickier. Here I'm given a right triangle, and I'm told that this leg has the same length as this leg, which means it's an isosceles right triangle. And the hypotenuse is given to be 9. And I want to find x. Well, x is equal to just 9 divided by the square root of 2. Now, 9 divided by the square root of 2, well, you know, that seems maybe okay to some people. Other people would say, you know what? I don't like that square root in the denominator. Let's rationalize the denominator by multiplying by a very special choice of 1, square root of 2 over itself, and then I see 9 square root of 2, and square root of 2 squared is just 2, and so I could write this answer as 9 square root of 2 all divided by 2. And that could be viewed as this length and also this length. So x equals 9 square root of 2 over 2. Very special 45, 45, 90 right triangle.